Hello. Hi guys, this is Navya and I'll be starting with the webinar soon. So I request all of you to join. We will start with the webinar as soon as the people join. Guys, please who have joined, inform your friends also to join as soon as possible. I'll be starting at 10:05 exactly. So I request you to inform your friends to join as soon as possible. So guys, in this session, you are free to ask any doubts you have in the comment section and I'll be answering your doubts. So feel free to ask anything you feel that is difficult for you and you're not able to understand it. So okay, I'll be starting with the session now. I'll introduce myself. I am Navyaa Sharma and I'm the core committee member of CodeChef-VIT and I'm from the technical domain. So as you must be knowing that today's webinar is on something related to C++. And in C++, we have a provision of STL that is known as Standard Template Library. So this will be the topic for our webinar today. So I hope most of you have joined. So I will be starting it. So now when we go into Standard Template Library in C++, C++ has like a lot of collection of various predefined classes which is included in this library, and this library is given name as Standard Template Library. So we'll be talking about what actually is included in this STL and what is it. So when we talk about STL is basically a powerful C++ template class set. So what is a template class? What actually a template means? So I'll be going through all of that. So basically what I want to tell you is STL is basically something which is containing various predefined classes that are just ready to use for you. Like they're given to you use readily. Like in Python also you must have seen that there are many functions that are readily available. So you don't have to write the whole code for that. So here STL is also going to help us with the same thing. So I'll be talking about what actually a template means here is. Okay, so template, what actually a template means is, template is a keyword. So this template is used to define various function templates and class templates. By template, what we understand is, template is something that is used to generalize something. Like suppose I want to generalize a class. Suppose I say I have a class that takes only integer data types. So that means my code is only useful if I pass integer values only to the code. What if I want to pass float values? So in that case, my code will fail. So I want to make my class generalized so that every value, every data type value can be used in my code. For example, I can take this class. This class is named list. You must be familiar, you must be having some idea with the classes. We don't have, I won't be going much into much depth of classes. Just I'll be telling you this is a class list, and in that class list it has a member called as A, which is an array. Okay, it is an integer array with a size of 10. So in this class list, I've defined this integer array. That means that this array is only of integer type, and only integer values can be taken by this array. No other values can be included in this. Okay, so now I close this class bracket. So this is my class definition. Now, if I want to define an object of this class, I say list L1. Okay. So now when I say list L1, now what will happen is, suppose when I run my code and when I say that I'm passing integer values and using this array, then that code is working fine. But what if my class needs some float values to be passed? Since this array is only going to accept integer values, so float values won't be taken into this array. That means our class and the whole code will fail here. So is it that I have to make various different classes to pass all the data type values? Like I'll make a different class to pass float values, then I'll make a different class to pass string values. Is it? Like that is such a redundant way to approach a particular problem, right? So we are modifying and improving this solution, and we are going to something known as template classes. So what are we going to do is, we are going to generalize this class so that it is going to accept every data type value, and this array can store any data type value. So what I'm going to do is, I'm going to write template class X. This X is basically a name that I give it according to me. You can give it any name. Okay, so if you give it a name, then you can use this X here. Like you won't write integer A10. You don't need to write in data type. Now X is your data type, and this X is a generalized way of defining all data types. In this X, you can pass any data type you want to pass in this array. So now I am defining this array of X data type. Now my X, this is the X data type array, and I can pass any data type values to it. If you want to pass float, integer, string, you can pass anything to it. So this is a general solution for this class. So I made it a template class. Now if I want to make an object of it, I'll say list, and then in the triangular brackets, I'll write the data type that I want to pass. Suppose I say I want to make it a float object. Like this will only accept float values. So I can make it as list float L1. If I want to accept only integer values, then I write list int L1. Okay, so this is the concept of generalizing a class, and in this way a function can also be generalized. So this is what actually a template means. Template is basically used for generalizing a particular class or function so that it can be used to by all the data types. Okay, so when we go back here, what we now we understand this line. Now we know what actually a template is. So STL is a powerful set of C++ template classes. So this means that we have readily available classes which can accept all the data type values in the single class. We don't need to make different classes for all data types. Okay. So now next, when we go to the second point, as a core of standard template library in C++, like there's so many classes in STL, so we are dividing those classes into three categories. One is containers, second is iterators, and third is algorithms. So by containers, what we mean is that that is something that is going to contain your value, right? Suppose you have an array that is going to contain the values that you provide. We'll look more into it, and what actually algorithm says here is, it's basically not the algorithm that you study in DSA. By algorithms, what we mean is, like you must have studied in Python that there is a direct function to sort a list, right? So that is a readily available function. You don't need to write the code to sort that list. You just use sort and the list name, and the list gets sorted. So just the same way, in algorithms also, we mean that there are predefined written algorithms and they're available as functions. So we can directly use them, and it is going to make our work easier only. So we talked about templates. Now we're going to study about containers. So in these containers, if you even have a basic idea of what data structures is all about, data structure contains arrays, linked lists, trees, heaps, and all that. So you don't need to go into deep because of for studying this webinar. You just need to know the names of various data structures. So what actually containers are going to do is they're going to hold the values that you provide in different data structure formats. Okay, so and we need to make these containers generic so that they can hold elements of any data type. That's why we talked about the concept of templates. Okay, so yeah, vectors is a very important example of containers. Now vectors is basically a dynamic array. Okay, so if I talk about a dynamic array, what dynamic means is something that is not static, right? Something that is, you cannot say that it has a fixed size of length 5, a fixed size of length 10 that cannot be changed or something. Dynamic means that it can be changed according to your time requirements. Okay, so we'll talk about the vectors and we'll write a code to see how vector works actually. Okay, now we'll go to containers. There are some type of containers I mentioned here, and we'll be going through most of them: arrays, vectors, list, set, maps, tuple, and pairs. So I'll try to cover as much as possible in this 1 hour video. Okay, so first we'll be starting with arrays. You must have studied what actually array is. Like when you go through basic knowledge of C or C++, array is always there. So you must be knowing that array is a continuous memory location readily available to store data. It's a sequential memory location available for you to store data. So this array is a collection, it's a container library, and it's a collection of classes. Okay, so array is also a template class available in STL that is going to make your work easier. So how is it going to work actually? I'll show you with the help of code. Okay, so just before writing the code, I'd like to inform you that you must be aware of the basic syntax, like how we write C++ programs. Okay, so you have to include IOStream. Then, like I said, that this is a template class. Now, my array, I'm going to use array as a template class. Okay, this is a different way, like how we used array before knowing STL, and this is how we are going to use arrays after using STL. So array is a template class here. So since it's a class, we need to include it, #include array. You need to include array, then only you can work with this template class further in your code. Otherwise, it will give an error that you haven't made the compiler already aware of that there is an array class or not. Okay, so you have to include this first. Then we'll start with the code. So suppose I want to declare a variable of array template class. Okay, so I'll write array. Then as I stated, I have to write the data type here, int. Then I'll write any name I want, like any identifier that I want. I'll say A1. This is the name that I gave according to me. You can name it anything. This A1 can be named anything. So I'll write array A1. So what is it going to do for me is that it is going to create an array of integer data types that will only accept integer values. Okay. So I can also write it something like this. We can also declare it something like this: array int, and then we can state the size, like how much long I want it, and write it A1. So what is it going to do is it is going to create an array A1 that is of size 5 in my memory location. And one more way to define it is, like suppose I want to define it here only, my array value. So I'll write array int 5. This is the size of the array that I want to create. This is the data type. And then I'll write the integer values. Any integer values you can write. That's it. Now you defined your array here only, that is 1 2 3. Now since my size was 5, so I'll take 2 more values. So now this is a 5 length array. then what I suppose I'll go through all the functions that are available. Now I've defined the array here. Suppose I want to access the second element. Okay, now suppose I want to access this 2 over here. That means that it is available at the first position. So I'll write array a1 dot, you can also use a1, then you can write 1. This means that sorry, yeah, you can write like this. This means that the element at the first index will be fetched. That means that 2 will be fetched. So I'm displaying 2 here. Or there's another way to do display the same thing. You can write a1 dot at, and then you can write the index location. So both the things are going to fetch you the same result. Okay, I'll write endl here so that you don't get confused. Don't forget to put semicolons, otherwise it will give you an error. This is endl. Okay, so I'll run this code for you. First you need to compile it, then we'll run it. It's a bit slow. Yeah, so you can see the output is 2. That means that both the statements did the same work and they fetched the number that is present at the index location 1. Okay, so this was the way to print the array at that location. This is a 2-type way. You can choose any one of them. So now we'll go to another function available directly. Suppose I want to, if I have an array a1 and I want all my like if the size is 5, all the sizes should be filled with the same element, then I can use a1 dot fill, and then I say I want to fill the whole array with the same element as 10. Suppose I do this. Okay, so a1 dot fill 10, that means all the elements will be 10 now in the array. So these will be overwritten and it will be 10. Suppose I want to check, then I can write yeah, that's the way how I'm printing all of the elements. Now I'll run it. Oh, I'm sorry. First you need to compile it, then run it. Otherwise it will give you the previous output. See, you can see 10, 10, 10. I didn't put the end line, new line character. It is giving you in the same line. So it is going to give you 10, 10, 10 5 times. That means all of the elements have been overwritten by 10. That's why we use fill function. And there's also another function. Suppose I say I have 2 arrays and I want to swap their values. So what we generally do is we are going to write the whole swapping code for swapping each and every value in the array. So for that, when you're using STL, we don't have to write the whole code for swapping. What we'll do is key will directly swap the elements by using just a simple function. Okay, but for that there is a condition that both the arrays that are being swapped, they have to be of the same data type, that is integer or any other data type. The data type should be same and their size should also be same. Like suppose if I have 5 elements in this also, in the second array also, my number of elements should be 5. Okay, so these are 5 elements. Now if I say that a1 dot swap and that is second array is a2. Okay, now what I'll do is you remember what was in a1 and what was in a2. What I'll do is first I'll print a1, then I'll copy the same code, then I'll print a2, Yeah. I'll insert a new line so that you don't get confused. Now first you compile it, then we run it. Yeah, so you can see what we printed first is the elements of array 1. Okay, earlier the elements of array 1 was 1, 2, 3, 4, 5, but now when we swapped and printed, they became 10, 12, 1, 1, 3, 15 and 19. That is the error. That is the elements of second array. That means the elements, all of the elements got swapped with their corresponding positions. So here we don't need to write the whole code for swapping. We just need to remember the basic swap function, that how we are swapping the two arrays, and this is going to make your work more easier. So that is yeah, there is one more function available. Suppose I say I want to access the first element. I'll write a1 dot front, and I'll write a1 dot front over here. Suppose I want to access the last element of the array, then there is a function called a1 dot back that is going to return the last element of the array. So I'll print it. Yeah, I'll run it. Now you see, actually it's not 15, it's 1 and 5. I didn't give the space. There's no element. If you talk about a1, there's no element 15 in this array. So the output of the first is the first element, that is 1, and the last element is 5. So you get 1 and 5 as the output. So if you have any doubts, you can ask in the comment section. Then we'll move forward. Like almost the functions of array have been covered. Now there is another function in array that is known as size. So with that, you can know the size of the array. So there's a function called size, a1 dot size. So if I do with this, yeah, so you'll get 5. That means the size of the array a1 is 5. That's a basic simple function. These functions can be easily remembered, and it is going to make your work easier only. So that's why we prefer STL, using STL. Okay, that was the end of array. I think I included most of the functions that were necessary to be taught in the array template class. So we'll move ahead with something known as pair. So what actually a pair is, what actually we understand by the term pair is that we are pairing two different kind of things together. That I suppose you can say they have some association when together, and they have to be paired together. Suppose I can say that there's a name and that there are person marks. Like there's a person and his marks are there. So I want a relation between them. Okay, so I want to develop a relation between them. So I can use pair. So I want them to be associated with each other. So I'll use pair in those cases. If I want them to always, if I always want them to use together and have a relation with them. Now, if I go to pair, pair is basically something like that what I told. We are associating two different things together and we are keeping it together as a pair. Okay, so this is the way you declare a pair. You write pair, then you need to write two data types here, because this will be the first element in the pair and this will be the second element in the pair, because in a pair we need two elements obviously. So you can write any data type here. It can be int here, float here, any data type you want to associate together, and then this is the name of the pair that you want to give. Okay, so yeah, we'll work with the pair. One more thing, while working with the pair, you don't need to include hash include pair, because that is not necessary here. Directly, if you write pair, then string and the int, both the data types I have taken, then I write P1. Okay, this now I have created a pair P1 that will take string and integer data type and associate it into a pair. Okay, now suppose I say I want to insert a value into the pair. So what will I do? I want to insert a pair actually values. So I'll say P1 equals to make pair, and then see what I'll write is my first element is of data type string. So here also I need to write the string element first. So I'll write Navya, and then suppose and the second element is int. Suppose it's my marks, and I'll say these are my marks, and then I'll write it like this. This is the complete statement. What is it going to do? It's creating a pair. It is going to map my name with my marks. Okay, so this is I created a pair and inserted a value into the pair. Now suppose I want to display it. So I'll write cout. Now while displaying, we have to keep in mind that since the pair has two elements, like first is my name and second is my marks. So I want, suppose since it has two elements, so I have to display it accordingly. Suppose I want to display my name, that is the first element in this pair, and this is the second element in this pair. So I'll write P1 that is my pair name, dot first. So P1 dot first should display my name, and cout P1 dot second should display 80. That is my marks. We'll try it out. Yeah, see, that is Navya and 80. I still forgot to add the new line character. I'm sorry for that. But if you want, I'll add it. Yeah, now this is Navya and this is 80. That means the output of the first line is P1 dot first, that is my first element in the pair, and this is my second element in this pair. So Navya and 80 are the output. In this way, you can associate any pair values together. So if you want to keep them together always in your code. Okay, so this was that's it for the pair, because only these functions are available in the pair. Now I'll go to vectors first, because vectors is like very important, and vectors are like used widely in C++ while using STL. So we'll go to vectors. Yeah, vectors, that, as I said, is the most general purpose container, and it is used widely, and it has a like if you understand it perfectly, that will be very helpful for you. So as I stated in a previous example also, vector is a dynamic array. So what do I mean by a dynamic array is, like suppose when I create an array, I say that I have an array A1 and I have its size 5. That means I have to declare the size of the array when I declare the array data type. Okay, so I have to state the size also. Before, without stating the size of the array, my code will give an error. So I have to state that my array is how much long and what is its size. So, but if I talk about dynamic array, what actually dynamic means here is that I don't need to have a size here. Vector is a dynamic array. That means a vector, when I'm declaring a vector, I don't need to give it size. I don't need to say that it is 5, the size is 5, and only 5 values can be inserted in vector. You can insert as many values as you want according to your requirement. You don't need to give a size over there. The vector's size will keep on expanding on depending on how many values you insert into the vector. So that is the reason why vector is being used more popularly than arrays, because you never know, like if you work in an organization, you never know. Suppose you say I have only record of n employees and I'll insert the data of n employees using an array. What if another employee joins and you have n plus 1 employees now? So but you can't insert more than n values into the array. So you need to change the code over there to insert the other value. But if you use the vector concept, you don't need to write the size thing, and you can insert as many values as possible like it won't give any kind of error, and vector is something that will expand its size according to your need only. That is why vector is more popular than arrays. So this is the way how we define vectors. It's similar to array, but just we need to include this keyword vector. Then the data type of the vector, you can write float, string, anything over here. I've taken int, then the name of the vector v1. And we are initializing it with some values, 1, 11, 12. Even if we don't initialize, it will be a vector of 0 length. So we'll go and code some of the functions that we have in vectors. Yeah, so this is our vector. So as I told you, it's a dynamic array. No need to declare its size as we did while declaring arrays. So I'll write, I included, just remember this, we need to include #include vector over here, because without that it won't work. It will give an error. Vector, then I'll write the data type int, then v1, and I'll initialize. And if I don't initialize anything, this is my 0 length vector. No elements are there in the vector. If I initialize it as 1, 2, 3, 4. This is my vector which contains 4 elements, 1, 2, 3, and 4. So now, suppose if I want to display the elements of the vectors. This displaying thing is same as what we learned in arrays. Like what we learned in arrays was we can use 2 methods to display the elements. We can use directly, like we did the primitive way, like you write the vector name and then you state the index location you want the element to be displayed, or you can use the add function. The add function is also going to return the same thing. So here also we can say, I'll show you with at only. You can try the second method at your own. I'll say at second location. That means 3 should be printed as the output. I can see out. I'll run it. And see, you get 3. That means it is the same way how we printed the values in the array. Okay. Yeah, so we know how to print the values of the vector. Now there are many other functions that we have in vectors that are very important. One of the functions is known as pushback. So what this function pushback does is, suppose you have to insert that, what I said, that we can insert any number of elements in vectors. So for that there is a function known as pushback. If you want to insert, suppose I want to insert 5 at the end, after 4. So I'll write v1 dot push underscore back, and I'll write 5. If I write 5, what it is supposed to do is that it is supposed to push this 5 value after 4, and now the vector v1 will contain 5 elements. So yeah, you can, if you want to check, we can use this for loop. We'll copy the code for loop that I wrote here. Yeah, okay, I'll change this to v1. Now since the result should have 5 elements in total, so we will check if it works or not. Oh sorry, that's the previous output. First compile and then we'll run. Yeah, see, 1, 2, 3, 4 and 5. Previously we only had 4 elements. When we added 5 using the pushback function, the element 5 got added at the end of the vector. Okay, this is the use of pushback. Then there is another function known as popback. What it does, it is going to pop off. Pop off means that it is going to remove the value that is present at the end of the vector. It will pop it out. It will remove that value. So okay, what I'll do is I'll change it to change the code here only. I'll say pop underscore back, and that's it. You don't need to pass anything inside it. Then when you write Popback, what it should do now is it should remove 4 and there should be only 3 elements left. So we'll check it over here. Okay, semicolon was missing. See, the element 4 got popped off, and it got popped off and only 3 elements were remaining. So we displayed those 3 elements over here. So output is 1, 2 and 3. And I covered pushback, popback, and the size function is same. If you want to display the size of the vector, you can use v1.size. It is the same function as I told you in arrays. You can use that same function. Now there can be a case when I pushed an element at the back. I deleted an element from the back. Suppose I want to I have a vector and I want to insert something in the middle of that vector. Something I want to insert at a place that I want in the middle of the vector. So what is the case? What does the case look like is I have this vector. Suppose it has these values, and these are the index location of those values. And I want to insert an element between the between 35 and 21. I want to insert it here between the second and third location. Suppose I say I want to insert 30 over here, 30 between them. Okay, I want to insert an element between second and the third location. So what I will do is I'll make use of something that I told you. They are known as iterators. What iterators are? Iterators are used to iterate with the data that is present in the containers. That is, suppose you have a data present in your array or vector, so you're going to iterate through it. By iterate, you can understand you're going to loop through it. Okay, so for inserting the data in between a particular value, what we'll do is we'll write vector. And then this is a different concept which is using iterators. So please pay attention here. And then I'll write int. This is the same thing. It is nothing new for you. Vector, that this is same vector v1 that has the data type int. And what we are doing is this is the scope resolution operator that we are using here. This is the syntax of using iterators. Then we'll write iterator. And then we give a name to the iterator. Suppose if I give it name as IT, this is the name of this iterator that I'm defining, IT. Then I'll put it equal to v1 dot begin. Now what this v1 dot begin is actually, yeah, I wrote this line. What this v1 dot begin is actually going to do is, see, yeah, what this v1 dot begin is actually going to do is the iterated IT that I defined over here. Iterator is basically it is going to point to a value that is present in the vector. So you can consider it as a pointer. Okay, so it's a pointer that is going to point to the beginning value of that vector. v1 dot begin is going to make the iterator point towards the beginning value. IT will point here at this element 1 at the first location. Iterator is going to point to the first element of the vector. So it will point here. Now, since I want to insert the data between 35 and 21, that is between the indexes 2 and 3, what I'm going to do is in my code, I'll write in the next line. This is the way how you define iterators. And in my code, I'll write is v1 dot insert. Insert is the function over here, and then I'll write it, that is my iterator value. Where is my iterator? Now it is on the first element. and I want it to go to the second element so that I can insert the data between second and third element. IT plus 2, then I'll separate the comma and I'll write what data I want to insert. I want to insert 30. Yeah. So what is it basically? Why I wrote IT plus 2 is because IT was originally at the first element, and when I write IT plus 2, it is going to go to this, and it will when it will reach here, then only it is going to insert 30 between 2 and 3. That is why I wrote IT plus 2, and then I wrote the element value that I want to get inserted. Yeah. So okay, I will copy this code over here. Okay, so this is going to now insert the value 30 between. So now in this case, we have 0, 1, 2, and 3. So it is going to insert 30 between 3 and 4. Okay, because the data in that example and in this example is different. So it is going to insert the data between 30 between 3 and 4. So now let's check it once. See, actually, yeah. Now we can see what happened here is 30 got inserted. So what 30 got inserted. So what I did here is just that I want the iterator to point to the beginning of the vector, and then I'm going to move it ahead where I want to insert my 30 value. Okay, so this is how we do it. Yeah, that's it for the vectors. Basically, I covered all the functions like pushback, popback, size, and if you want to, how you want to display and how you insert data between any two values in the vector. And there is another method known as v1.clear. What is it going to do is clear will basically, I'm sorry, I didn't put dot. v1.clear. Clear will basically clear the whole vector. No element will be remaining in this vector. It is going to clear the whole of the vector, and it will create a vector v1 of size 0 back again. So this is a simple thing. You can use clear if you want to clear all the values in that vector. That's the end of the vector. We mostly covered all the necessary functions that were required. Okay, so after completing vectors, if you guys have anything to ask, you can ask in the comment section. Okay, no one posted. So, okay, we'll move to the lists now. List term, I hope you all are familiar with something known as list because there is something similar in Python also. So this is in STL also. List, by list, maybe you understand something. Some people may understand that it's a linked list or an array sort of a thing. So what list mean here in STL is basically that a list can be accessed sequentially only. Like you have to go in a particular manner. Either you have to start from the beginning and access it sequentially, either you have to start from the end and access it sequentially. That is why we call it bidirectional. You can access it from front to back or back to front only. You cannot you cannot access it randomly. Like suppose I say there is a list containing 5 elements, and I say, you take this example, there is a list containing 3 elements, and I say I want only the second element, that is the mango. So I can't write that L1 dot at then I'll write 1 because the index is 1 here. That won't give you the result. That is going to give an error because this function is not supported here. You can't access randomly any data present in the list. You can only go from front to back or back to front in a sequential order because it's a bidirectional list. Yeah, okay. So we'll work with some of the codes. Yeah, here also, see, I have included hash include list. You have to do this, without that you will get an error. And I'll write list, then I'll state the data type of the list, int. It is a similar way we did the previous containers, list int, and I'll name it L1. Then I'll say 1, 2, 3 something. Okay. Now this is my list L1. Since I already told you I can't randomly access any of the values present in the list, I can say ki I want 2. So I'll write L1 dot at first position. It will display 2. It won't display 2. We have to access it from the beginning only if you want to see 2. You can't directly access 2 here. Okay. So this is the L1 list and I've declared. Then suppose I want to display all of the elements in the list. So what I'll do is, for displaying the list elements, iterator's concept is used, and the iterator concept is very important because list and vectors are like the most frequently used things in STL. So I'll give you the basic idea of iterator, how to work with iterators. So as I mentioned an example previously also, so for displaying the elements here, we can't use the previous way that we use, like here. What we did in arrays was we did a for loop and then we wrote this code and all of the elements got displayed. But we can't do the similar thing in list. We have to use iterators over here. Yeah. So what I'll do is list, then the data type. Then I'll use this resolution operator. Then I'll write iterator and I'll name iterator as IT. Then I'll give it equal to L1 dot begin. As I already told you, L1 dot begin is going to point to the first element, that is 1 here, is going to point to the first element in the list. So now I have to find my iterator IT. Now what is it going to do is, now I want to display all of the elements. Now I have to go from front. You have to start from the front and go to the end. Okay, so I have to go like this, in this order. So I have to start from the front and go to the back. So what I'll write is, while I need to make the use of a loop, I'll use the while loop. While while IT is not equal to L1 dot end. So what L1 dot end is going to point to? L1 dot end is going to point to the value that is present to next of the last value. Like, it basically means it indicates the end of the list. This L1 dot end is going to indicate the end of the list. So while the iterator doesn't reach the pure end of the list, the while loop is going to work. And once it reaches the end, the while loop will terminate. Okay, so while IT not equal to L1 dot end, what we are doing is we are displaying cout star P, then I'm incrementing P. Since I told you, so sorry, actually I mentioned P, it should be IT. Yeah, since I told you iterator is basically a pointer that is pointing to the different array values. So for displaying the value present at that pointed location, we'll use star operator, and then I'll say star IT, and then I'll plus plus. IT plus plus means that I'm going to the next location. My pointer will point now to the second element and then display it. I give a space over here. That is the end of the while loop. Okay, so we'll try displaying it. Yeah, see 1, 2 and 3. That is what I stated in list L1. And using the iterator and the pointer concept, I use it to display the elements in the list. So I got the output. So it is very simple. In case you have any doubt with the iterator, you are free to post it in the comment section. Iterator is basically what it is going to do is it is going to start pointing to the first of the list, and then it is going to increment its value, and then it is going to go to the next value in the list. And then for printing the value present in the pointed location, we are going to use the star operator. That's why we have used the star operator here over here. So this is how we print the elements in the list. Now there are also many functions available in the list. Some of them are similar to what we used in vectors. So I'll just mention them because I have to cover a few more concepts. I'll not do the same thing over again. Pushback. Pushback is again pushback. Basically, what is it going to do is it will push an element for you to the end of the list. So I went through the pushback function. Then there is popback. Popback is also the similar thing. It is going to pop the last element present in the list. So pushback, popback, and similarly there is something known as push front. What push front is going to do is what push front is going to do is the element that, suppose I say push front 23, what is it going to do is it is going to insert 23 before 1, that is at the beginning of the list. Now 23 will become my first element. That is what push front does. It is similar to push back, but just back and front are different. Otherwise it is going to do the same thing. Then similarly we have pop front, that it is going to pop the first value from the list. Okay, so we are done with this. And then there is a function known as sort, which all of you must be familiar with, sort function. Then there is a function called reverse. This is going to reverse the list. Okay, so we'll try the sort and reverse function once. I'll say L1 dot sort. Actually it's already sorted, so what I'll do is I'll make it 11 now. Okay, now we'll see L1 dot sort. Yeah, then actually I'll put this and copy this, and then I'll put it over here, so that this cout this is going to help you display the elements of the list. So what I'm doing is I'm declaring a list that is containing 11, 2 and 3 as the elements, and I'm using sort function to sort the list, and then I'm displaying the elements using this iterator thing. I'm running it now. See, you have a sorted list over here. The 11 was the biggest number, so went to the end, and this is the sorted list over here. Basic sort function, you don't have to write any code over here to sort the whole array or list, whatever. Basically a sort function is available ready for you, and you should know how to use that function. You should know how to make use of the function correctly. The functions are already available for you. Like this, you can use reverse. See, now the elements got reverse. 11, 12, 3 to 3 to 11, 2, 3 to 3 to 11. The list got reversed. Okay, so I covered pushback. You can try these functions at your own. This is similar what I covered in vectors. So you can use that thing to do it on your own and try it on your own if you're able to do it or not. And I covered the sort function, reverse function, and this is the most important thing, like how you display the list using iterators. This is just a basic idea that I'm giving you, because we don't have much time. So this is all about the list, and that's it. We mostly covered mainly the major containers that we had here. I covered list, vectors, pair, arrays. With list, there is also another container called tuple. So tuple is also similar to list. List and tuples, I think you're familiar with what list and tuples are. You must have studied it in Python. So tuple is something which is immutable, which can't be data can't be altered. So it is the same. Tuple is the same way. That is, it has the same format what we studied in the list. So you can try tuple out on your own. And if you have any doubts, you can like contact any of the technical members or any of the core members. And still I have time, so you can ask any of the doubts you have in the comment section. I'll answer them. In this 1 hour session, I tried to cover what all actually was the most important things. So maybe we'll come with another session and continue this. So if you have any doubts, you can post it in the comment section. I'm waiting for you guys to ask something. I think you understood everything. Okay, cool. I'll suggest you to practice more on this. You can go to HackerRank and practice problems. Like, if you have any doubts, feel free to PM any one of the core members. We are here to help you. So I'll be ending this session over here. And I hope that was quite informative for you all. So, okay, thank you for watching.